in the nucleus. Low uracil levels. Forget that DTP thing, I don't care. Just notice the U. Relatively speaking, we have a lot of T and not a lot of U. Folate deficiency changes the ratio to relatively higher U to T than would otherwise occur. The more U's there are in place of T's, the more single-strand breaks there are. Because can you pair a U with a G? No. You can only pair a C with a G. So if you accidentally end up with a U, then the thing just falls apart. You no longer get that bond, and when the thing falls apart, the DNA is not winding around the histone proteins. It just breaks, and you can't put it back. And that's why they're talking about these giant nuclei. Because they're giant nuclei because all the DNA is splayed all over the place, as opposed to being wound correctly. Okay, so the more U's there are in place of T's, the more single-strand breaks there are. So the more double-strand breaks present, in other words, U for T in both strands, that's a bigger problem, the more the cells will die. This is a non-recoverable event for DNA. It cannot be repaired. In other words, if you've got an oops in one strand, you can go back and fix it. If you get an oops in both strands, it's over. That cell cannot repair that part of DNA, and that cell has to die. Like, it can't replicate, and when it's done, and it can't do its job either, right? Okay, so then you get stuck. You get lack of cell division. You get stuck between DNA synthesis and replication and mitosis. You just look like this giant blob of DNA frayed out in the middle of everywhere. This is associated with an increased incidence of certain cancers, so there's a nutrition insight there. So we talk about DNA methylation and epigenetics. We talk about the folate status paradox, which I'm going to leave, because you're going to read this thing. You're going to read this nutrition insight for Wednesday, and it's going to show up on the exercise, and we're going to talk about it. And then you get an increased risk for vascular disease. Persistent hyperhomocysteine is a known risk factor for vascular disease. But giving B vitamins doesn't help prevent heart attacks. You get these neural tube birth defects, right? Folate supplementation. They don't actually know why it works. They're not totally sure. But in the formation of the embryo, the neural tube is formed by neural crest ectoderm at a very specific time in the development of the embryo. So if you don't have methyl groups available, it may be that you don't shut down what needs to be shut down. And if you can't shut it down, then maybe you don't close the neural tube, right? So you can shut down certain genes by methylating them. If you don't have enough methyl groups, you didn't attach that to the DNA and it doesn't turn off. Okay, so there may be depression in neurological systems. These are questioned. Okay, so we're going to stop here. We're fine. We're only like 10 minutes behind, and I can make that up. Okay, so let me highlight the rest of this. Don't worry, it's okay. It just means I'll cut something out. It doesn't mean I'll go any faster, because I'm going super fast. So, all right, I've just highlighted like everything. Sorry. We're going to come back, and we're going to spend 20 minutes on folate at the beginning of next time. We're going to review